We're going to continue on with using log rules to solve equations. We're going to leave our warm-up for us to do in class as our warm-up, so you can skip over those for now. So we're going to solve each using logarithms. And so like I said, the easiest way I personally think for all of these, rather than trying to figure out which base to use, is just to take the natural log of both sides. So that's going to give me natural log of 3 to the x is equal to natural log of 11. The x is going to pull down in front, so I've got x natural log of 3 equals natural log of 11, and then I can divide both sides by natural log of 3. And that gives me about 2.183. Okay, if I do the same thing with this one over here, if I take natural log of both sides, it's natural log of 7 to the 3x is equal to natural log of 0.75. Okay, if I take that, 3x comes down in front, and I can divide both sides by natural log of 7. So it's going to give me natural log of 0.75 divided by natural log of 7. Now, I have 3 times that. So in order, I'm going to do natural log of, excuse me, 0.75 divided by natural log of 7, and I get 3x now is equal to negative 0.148, and then I'm going to divide both sides by 3, so that x is approximately negative 0.049. All right, one more. If I take the natural log of both sides, the negative 0.7x is going to come back down in front using my rules, and I've got the following. Okay, so I'm going to divide both sides by the natural log of 1.5. So natural log of 15 divided by natural log of 1.5 is approximately 6. So I've got negative 0.7x is about 6.679, and then I can divide both sides by negative 0.7. So I get negative, whoops, I accidentally divided by 6.679 divided by negative 0.7. There we go. Is about negative 9.54-ish. Okay. All right, so let's get a little bit more complicated. So again, I can just use that natural log no matter what. So if I take natural log of both sides, now I've got this whole quantity x plus 2 that's going to come down in front. So I've got quantity x plus 2 times natural log of 6 is equal to natural log of 21. So I'm going to divide both sides by natural log of 6, so that leaves me with x plus 2 on this side, and I'm going to have natural log of 21 over natural log of 6. So natural log of 21 divided by natural log of 6, Control Enter, and I get x plus 2 is about equal to 1.699, and then I'm going to subtract the 2. So subtract 2 from that, and I get x is approximately negative 0.3. It doesn't matter what the base is, okay? You can still do the same thing no matter what. So I'm going to do the next one. I just want to change my color, and I'm going to do B down here. Okay, so I'm going to take natural log of both sides. So that's going to bring the 4x plus 2 down in front. I have natural log of 10 is equal to natural log of 85. So I can divide both sides, since this is multiplication, divide both sides by natural log of 10. That leaves me to 4x plus 2 equals natural log of 85 divided by natural log of 10. Whoops, not 110, just 10. So that gives me 4x plus 2 is about equal to natural log of 10 and I get it's about equal to 1.929. So I'm going to subtract 2. And I rounded that, and then I'm going to divide by 4. So x is about equal to negative 0.0176. Okay, so now, the more complicated I get, my goal is to isolate the stuff that's raised to a power first. So for b, I am going to add the 3 over first and then get rid of the 4 over 5. So I'm going to do that one since it's the one of the most complicated ones we have on here. Okay, so I'm going to add the 3 over. So it's going to give me 4/5 times 9 to the x plus 2 power is equal to 16. Now in order to get rid of the times by 4 over 5, I'm going to multiply by the reciprocal. So I'm going to multiply by 5 over 4. Okay, so when I do that, I multiplied by 5 over 4, so that's going to leave me with 9 to the x plus 2. Okay, 16 times 5 over 4, so I've got 16 times 5, which is 80 divided by 4 is 20. Now I can take the natural log of both sides since it is the stuff raised to a power is isolated. I'm going to take the natural log of both sides. And that's going to leave me with x plus 2 times natural log of 9 is equal to natural log of 20. So I'm going to divide both sides by natural log of 9 to give me x plus 2 is equal to natural log of 20 divided by natural log of 9. And then I would subtract 2 from whatever that answer is. So I'm going to do natural log of 20 divided by natural log of 9. And then I'm going to subtract 2 from that answer. So when I subtract the 2, I get approximately negative 0.637 when I round. So one more. If I do C, okay, I'm going to change colors here. Let's do red. I'm going to isolate the 15 to the 3x plus 4 power by subtracting 43. So if I do 17 minus 43, I get 15 to the 3x plus 4 power is equal to negative 26. But wait a second. I know that an exponential function, unless there's a negative out in front of it, can never be negative. So this particular one, even though I have isolated the stuff to a power, if I were to take natural log of negative 26, I get an error because an exponential function, unless, like I said, unless there's a negative out in front, which means we would have to divide by negative 1 to make it positive, we can't get a negative number out. So there's no solution to this one. All right, so let's try example 4a. Okay, so I'm going to go ahead, since the exponential stuff is isolated, I'm going to take the natural log of both sides. So that's going to give me x plus 2 times natural log of 4 equals the quantity 3x minus 4 times natural log of 6. Okay, so there's a couple ways we can do this. All right, I think the easiest way is to, instead of dividing, because notice that if I just divide the natural log of 4 over the natural log of 6, it doesn't really get rid of anything to isolate the x. So instead, I'm going to carry the natural logs through to their sets of parentheses. So that's going to give me x times natural log of 4 plus 2 times natural log of 4. And then multiply the other side. So I'm going to have 3x times natural log of 6 minus 4 natural log of 6. So the stuff that has x's attached, I can combine those. I have to move them over because we're on either side of equal sign. And the stuff that's a number times a natural log, I can go ahead and combine those as well. So I'm going to subtract. I'm going to move this over here. Okay. Let's see, I think I ran out of room here. Okay, so I subtracted this over. All right, I'm going to erase a little bit here so that we can have some space up here to work with. All right, so I'm going to go up to the top here. So now I've got x natural log of 4 equals 3x natural log of 6 minus 6 natural log of 6, because negative 4 minus 2. Okay, that's a numerical value, this is a numerical value, this is a numerical value. So when I subtract over, so I'm going to go ahead and make an approximation here. So I'm going to say natural log of 4 is approximately, so this is approximately 1.386x. And then I've got natural log of 6, but I have to multiply it by 3 in this case. That's about 5.375x. And 6 natural log of 6 is approximately 10.751. So I can subtract the 5 over, so I've got 1.386 minus 5.375. So that gives me negative 3.989x's is equal to negative 10.751. So I can divide both sides by that negative 3 and change. So I've got negative 10.751 divided by our negative 3.989, and I get x is approximately 2.695. The hardest part about these problems really is just the fact that it's yucky numbers. All right, so we've done now that we're in exponential form, and solving, so we had to take the natural log of. Let's look at ones that are already in log form. If I have two logs equal to each other and they're the same base, I can just set what's in the parentheses equal to each other. What I have to remember, though, is that the stuff that's in the parentheses has to be a positive number because I cannot raise 5 to any power that's going to give me 0 or anything negative. So as long as I get out x values that make the stuff in the parentheses positive, that's considered a solution. So I'm going to subtract the x over to this side, so it's going to be 3x, and I'm going to add the 7 onto the other side. So I get x equals 4. So I just need to check and make sure that if I plug it in to the 4x minus 7 and the x plus 5, I get a positive number. I get 9 on this side, so that's good. 16 minus 7 is 9, so we're good. X equals 4 is the solution. All right, let's do a different color. How about this one? All right, so we've got same base, so I'm just going to, again, set the parentheses equal to each other. Now we've got a quadratic here, so I know it has to be equal to 0. I'm going to subtract the 3x over. And then so now I need two numbers that multiply to negative 15 and add to negative 3. So I'm going to use negative 5 and I would want to use negative 5 and 3, but the problem is that doesn't add up to negative 3. So I need to use the quadratic formula for this one. So this doesn't work. Factoring doesn't work. So I'm going to use x equals negative b over 2 times 1 plus or minus the square root of b squared, which is 9, minus 4 times 1 times negative 15. So 4 times negative 15 is negative 60, so that's going to become plus 60 over 2, sorry. All right, so I get 3/2 plus or minus the square root of 69 over 2. Now, if I look at the negative version of this, all right, 3/2 minus the square root of 69 divided by 2 is approximately 4. Okay, it's a little bit bigger than 4. So 3/2 minus this stuff is going to make this number negative. If I plug a negative number into this piece over here, I get a negative in the parentheses, which doesn't work. So that means my only solution is going to be 3/2 plus square root of 69 over